all of us are using steel products for different applications. So, it is important to know what we understand by quality of steel. Like quality of any material, then we have to ask what do we mean by quality. That is why what is important is to understand what is the concept of steel quality. If by one statement, if you want to understand what is meant by quality of steel, then it is conformance to specified application requirements. I have just tried to highlight conformance to specified application requirements. Please remember that every steel component or every steel product is used for a specific application requirement. For example, I can give you some examples. Say electrical steel, which is used for transformer or motor or generator, it has certain requirements. A steel which is used for tire cord, which is supposed to be a very stringent application, it has certain requirements. A particular steel product which is used for building construction, that has a certain requirements. So, always we have to keep in mind that by quality of steel, we basically should understand what application requirements it is meant for and whether this particular steel is conforming to that. That is why this is important to understand by quality of steel what we should mean conformance to specified application requirements. Now, if we understand that conformance by quality we mean conformance to steel application requirements, then let us try to understand by quality what do we specifically means. That means, what are the different attributes. For example, you take any product, it need not be steel, there may be many attributes like any metal or any alloy, it has a metallurgical attributes, it might have a physical attributes. Physical attributes basically I mean whether its dimensions are okay, whether dimensions are the flatness is okay, surface is okay, things like that. But basically in this course I will try to cover the metallurgical attributes. By metallurgical attributes, what are the different issues are there, what are the different factors. Let us go into it one by one. All of you know that every steel product must have a specified chemistry. That means, it has a range of chemical composition which it should conform to. Like if it is steel, all of us know steel basically has iron and carbon. These two are the important elements present in steel. But besides these two, there may be silicon, there may be manganese, there may be other elements, required elements like aluminum, whether it should be less than that or within a range. There may be sulfur, phosphorus, all these things are important. What is the range within which the chemistry is defined? So, the first requirement or the first attribute of a steel product is the specified chemistry. What is the ranges of different elements? Now, next important, out of these elements, some are residuals, some may be trace elements which may not find a place in the specification, but these are important. For example, by trace elements I will come to it slowly. What do we understand by trace elements? Trace elements like antimony, lead, zinc, things like the elements like that which are present in steel sometimes, and their origin is basically the scrap which from which the steel is melted. So, those elements are basically trace elements which are not desirable, but we should know that these elements should not be present in a relatively large amount, otherwise it might create problem for the application. So, we should know what are the residuals, what are the trace elements, and what are the limits for different applications. Now, another important requirement which is very important, all of us should keep in mind, they are the defects which should be minimum. By defects I mean the surface defects, or it can be internal defects. Like any product, certain defects may be appearing on the surface itself. So, we have to be very careful about those. I mean they should not be present beyond a certain limits. Similarly, internal defects which normally we cannot see with our eye, but by certain examinations like NDT and things like that, normal non-destructive testing, we might know what are the defects which are present internally within that steel component. So, those defects have to be kept within certain limits. So, that is very important. Now, another important requirement is the cleanliness. This is again a very important requirement. By cleanliness I mean what are the inclusions. I think all of you are possibly aware that all steels contain certain inclusions which are not desirable, but you simply cannot get rid of them. So, what is important is to keep those inclusions within certain limits. By inclusions I mean not only their size, their volume fraction, their distribution, everything is important. What are the inclusions, what are the chemical constituents of those inclusions, all these are very important. I will come to it later on that by inclusions I mean both micro and macro. Basically micro means which you cannot see with your normal eye. All of us know that what is our resolution of our normal eye. Possibly you have to go back to your physics understanding to recall that our normal eye resolution is 100 micron. Basically it is 0.1 millimeter. That means those inclusions or constituents in steel which are smaller than those cannot be seen with normal eye. So, that is very important. So, we have to use some microscope. So, that is why those are called micro constituents. So, our inclusions which are micro inclusions, to reveal those we have to see the steel component under microscope. Maybe you have to prepare, you have to polish it, there are certain requirements, I will come to those later on. But there are certain constituents which are macro in nature, that means their size is more than the 100 micron size which I am talking about, the resolution of our eye. So, those inclusions or constituents or defects which are more than 100 micron in size in any dimension, that means we can see those with our normal eye. For those we need not go to the microscope. So, those are called macro inclusions or macro defects or macro constituents. Now, another important requirement all of you must appreciate is the desirable microstructure and of course, the properties. Microstructure of any metal or alloy and of course, in steel is very important. Microstructure constitutes what should be the final properties, like all the properties, metallurgical properties like strength, ductility, all these things depend on the microstructure of the steel. So, every steel for certain applications should have certain properties, or those are called application requirements. To meet those properties we must have desirable microstructure. So, if you look at the different quality metallurgical quality attributes, first I have talked about the specified chemistry, then I have talked about the low residuals and trace elements, what are the upper limits for a particular requirements. These are not fixed, these are not sacrosanct. Depending on the requirements, the residuals or the trace elements have to be defined. Then the defects, again depending on the requirements, application requirements, those have to be defined. Cleanliness, again this is very important, depending on the application requirements, all these are defined, and of course, the final properties and the microstructure. So, if we look at all these metallurgical attributes, these are all very, very important. So, by quality we have to look into all these aspects. Now, let us try to understand where from this metallurgical attributes they are, what are their genesis, where from they are coming. So, there are two broad categories from which they are coming or they are generating. First of course, is they are inherited from the parent cast material. All of us must appreciate, the cast material is the starting point of any product. First you have to cast the material, like normal steel products, they are either ingot cast or continuously cast. So, that is the stage we call is the parent cast stage. After that, you have to roll it, forge it and things like that. That means you have to subsequently process the cast material to get the final product. It may be hot rolling, it may be hot forging, it may be subsequent cold processing, it may be subsequent any other processing, cold processing. So, some of the problems, some of the metallurgical issues, they are generated in the cast stage itself. So, it is very important to understand what are those and how they finally result in the defects or quality issues in the final product. And of course, during different processing, some are imparted. Those are basically called processing defects, and at this stage whatever we get, those are called material defects. So, there are basically two broad categories. One is the material defect and that is the processing defect. In this particular course, I will be basically talking about this, that means those issues which are related to or inherited from the parent cast stage. So, those are basically called material defects, material quality and material issues. The whole idea of this course is to try to understand what are those issues, at what stage they are getting generated, what are the steps to take care of those, things like that. And when these are coming, how to understand what are the defects and how to understand what is the genesis. So, all these issues one after another will be taken care of in this particular course. Now, as I have told you that basically I will be harping on quality issues of material origin and not quality issues of processing origin. So, let us now try to understand in broad categories what are these, how they are manifested. When you are looking at a particular product, steel product, for example, let us say we are looking at a hot rolled product or looking at a cold rolled product or looking at a hot forged product, then certain defects come on the surface itself, or it might require certain special tests to reveal those defects on the surface. So, those are called surface or subsurface imperfections on the products. So, those defects on the surface, they may be visible with normal eye, or certain tests may be necessary to reveal those which are on the surface of subsurface. Like certain tests, I will come to those, what are those specific tests. And another defect which you may not see on the surface, but those can be revealed during non-destructive testing. So, those are basically internal imperfection or internal defects. So, those have to be revealed through some certain tests, those are called non-destructive tests. So, basically there are two types of defects which can be manifested, either on the surface or which are present internally in the products. So, these are the basically two types of manifestation. Now, let us try to understand where from these defects are coming. So, what are their genesis, where from they are originating, this is very, very important. The cleanliness, as I had told earlier, is very important in this respect. If you have a clean steel, certain defects are within control. That means their volume fraction, their amount, their size, their distribution, they are within norm, that means what they are within their control. So, they may not create any problem, but certain defects when they are present either in size or in amount or in distribution beyond certain limits depending on the application requirements, they are, we call those things, it is called those defects as NMI, non-metallic inclusions. I have talked about inclusion, so these are basically non-metallic inclusions which are not desirable beyond certain limits in steel. Now, we have to try to understand that no steel is 100% free of inclusions. Even if you want any steel to be free of inclusions, it is not possible. The only point is the inclusions are within limits. Inclusions have to be within limits. As I am repeating again and again, either the size or the distribution or the volume fraction, all these things have to be within limits. So, if those are beyond limits, then we call the steel is unclean, that means your cleanliness level is poor. Now, what is meant by exogenous entrapment? Inclusions which are present in steel or non-metallic inclusions, to be more specific. Why we call it non-metallic? Because these are basically not part of the normal steel structure. These are undesirable constituents which are coming within the steel because of certain aberrations in the processing of the steel, or not on the processing, in the making of steel, in the preparation of steel, in the liquid stage itself or during casting, those are coming. So, those are called non-metallic inclusions. Now, certain inclusions can be, we call it metallurgical inclusions, that means those are part of the metallurgical process, that means those are generated during the steel making stage itself. As I have told you, even if you do not want inclusions in steel, they will always be present. Our job is to restrict those inclusions within certain limits. By exogenous entrapment, I mean what are the inclusions which are coming or getting entrapped in liquid steel from exogenous sources. For example, reoxidation. We do not want steel to get reoxidized, liquid steel to get reoxidized during the process of steel making, because we have many constituents in steel which are very oxidation prone. For example, we have aluminum in steel, we may have silicon in steel, we have manganese in steel, those will get oxidized. Even iron in steel, which is a major constituent, they might get oxidized in presence of oxygen. So, those are called exogenous entrapment. Now, all of us know that when we are making steel, liquid steel, they have to be kept in certain containers, we call it ladle. So, those ladles are lined with refractory lining, otherwise those are very insulating type, because the steel, liquid steel is very high temperature. To maintain the temperature, we must have some insulation. So, always there is a refractory lining in any metallurgical reactor. So, what is that called? Those refractory linings, they might get eroded. So, that is another constituent, we call it exogenous material, which might get entrapped in the liquid steel. So, we have to be very careful what refractory material we are using, at what stage there is a possibility of this, some of these constituents getting entrapped and things like that. So, basically these entrapments or non-metallic inclusions, they are related to the making, the defining and the casting stages. So, all these issues are very important. We have to be very careful at what stage they are coming and to what, by what means we can control them within the limits. I am again and again repeating, these have to be controlled within the limits. Now, when you are finally casting the liquid steel, there are certain quality issues of the casting as such. It may not be related to the entrapments or non-metallic inclusions. It may be directly related to the casting as such. That means, they might be related to the specific grade of steel, or the casting process itself. By casting process I mean ingot casting or continuous casting. All of you are possibly aware that these days most of the steels are being made through continuous casting, because there are a lot of advantages. The yield of steel goes up, the relative quality of the steel goes up, therefore the cost of the steel also will come down if we do the casting through continuous casting route rather than ingot casting route. So, what I was trying to tell, some of the defects or problems, they are originating from the steel making stage itself or refining stage, but certain defects or cracks might get generated at the casting stage. So, we have to be careful at different stages for the different types of quality issues which are getting generated. Now, let me first talk about the cleanliness requirements. I have told that these are application specific. That means depending on the particular application, there has to be upper limits for these cleanliness requirements. By cleanliness what I mean, now let us try to explain what do I mean by cleanliness. I have talked about residual impurities. What are those elements which we call residual impurities in steel? Let us try to go into those one by one. First is sulfur. All of us are aware that we do not require sulfur in normal grades of steel. Leaving aside machinable steel where you require some amount of sulfur maybe, but forget about that for the time being. Sulfur is an undesirable residual in steel. Next comes another important residual called phosphorus. We do not want phosphorus in steel because it might create many problems. We will come to those, what are those difficulties. Then oxygen in steel again is not desirable. We are making steel by putting lot of oxygen. All of us know that steel making is basically oxidation reaction, either in basic oxygen furnace or electric arc furnace. These are basically primary steel making stages where we are putting lot of oxygen in steel to oxidize some of the elements and remove those. So, we are putting oxygen in steel, but we do not want oxygen to be present in steel beyond certain limits. There might be a lot of difficulties or problems. Then another important residual is nitrogen. Again, I have talked about reoxidation. In the same process, renitrogenation can take place in steel. That means when steel is getting exposed to air where oxygen and nitrogen are present, like reoxidation, there can be renitrogenation in steel. So, we have to be very careful about nitrogen increase in steel. Again, depending on the applications, nitrogen limit is there. Nitrogen has to be controlled within certain limits. Another very important element which may cause difficulties in steel is hydrogen. Some of us are aware of hydrogen cracking problem. When hydrogen is present beyond a certain limit, we might get embrittlement in steel. That means the steel becomes brittle, crack formation might be there. So, the reason may be hydrogen. So, we have to be careful about hydrogen content also in steel. So, all these sulfur, phosphorus, oxygen, nitrogen, hydrogen, these are known as residual impurities. Even if we want or desire, we cannot make them zero in steel. Every steel will have certain amounts of this because of the process by which you are making the steel, but we can control them and keep those and restrict those within certain limits. That is what is desirable. Now, I have talked about non-metallic inclusions. What are those? When oxygen is present in steel, it will give rise to oxides. When sulfur is present in steel, it might give rise to sulfides. Try to understand when oxides and sulfides and nitrides, all these constituents are forming. When sulfur, oxygen, nitrogen, these are present in steel as soluble constituent. Beyond a certain limit, solubility, that which we call solubility limit, if these are present, this will come out as sulfides. If sulfide is beyond that limit, if oxygen is beyond the limit, it will come out as oxides. If nitrogen is beyond the limit, it will come out as nitrides. So, what is important is this constituent, this, that means oxides, sulfides or nitrides, these have to be controlled in steel. Their volume fraction, their amount, their sizes, all these have to be controlled. So, basically these are coming from the impurities. So, the basic problem is the impurities. If the impurities are present beyond a certain limits, non-metallic inclusions will also form, and if they are present in very large amount, non-metallic inclusion constituent, their size also will increase. So, these two are interrelated, impurities, residual impurities as well as non-metallic inclusions. Now, let me come to the trace elements. I had mentioned it earlier. What are the common trace elements in steel? Say arsenic, tin, antimony, copper, lead, even zinc. These are called trace elements which we do not desire in steel, but they may be present based on where from the scrap we are used. These are coming from the scrap or the or the starting material which is used for making steel. So, certain amounts of these may be present depending on where from those starting materials are coming, what are their origin, like the ferroalloys, where from they are coming, what are their origins, things like that. So, all these constituents have to be controlled within certain limits. Now, as I have told, the amount, chemistry, size, distribution of these non-metallic inclusions, they are very important in steel. So, they should not affect the desirable microstructure and finally the properties. If the inclusions are more, if you have certain problems, certain difficulties, so we should know what are the inclusions present, types of inclusions, what is their amount, what is their volume fraction, what is their size, what are their distribution, things like that. So, everything is very important here, amount, chemistry, size, distribution. Not only the amount, sometimes we call that so much of inclusions are present, that is only one aspect. What are those inclusions, what are the sizes, how they are present, all these are important. They should not affect the desirable microstructure and hence the desirable properties. That is what is important. They should not affect the surface and internal quality. If these inclusions are present in very large amount or the sizes are not desirable to the desirable limits, within desirable limits, you might get surface problems, you might get internal problems. There may be NDT failure if inclusions are more. If there is a line of inclusions, we call it a stringer of inclusions, there may be NDT failure for a particular applications. So, these are very important. Now, let us try to understand. I have talked about what are the residuals. How do we control in steel? I have talked about phosphorus. This is a very undesirable element. This is controlled during primary steel making stage. By primary steel making, I mean either BOF, basic oxygen furnace, or electric arc furnace. This phosphorus at this stage can be controlled to less than 0.25% by using basic slag. Basic slag basically means which is rich in CaO. Basicity is defined by CO by SiO2 ratio of the slag. That means the slag constituent has to be very rich in CaO, so that phosphorus oxide which is formed in BOF or electric arc furnace by oxidation reaction, which can be taken care of by CaO. So, during primary steel making stage, phosphorus can be controlled within 0.25. So, it is a very desirable requirement. Now, let us talk about oxygen, which is another residual. I have talked to you about whether oxygen is present in dissolved stage or as inclusion. Now, in BOF or electric arc furnace, because it is an oxidation reaction, lot of high oxygen, dissolved oxygen is present, it may be more than 500 ppm, it is quite high. Now they have to be brought down, otherwise that steel becomes undesirable or unfit for certain applications, all applications in fact. So how does it, how it can be brought down? It is by deoxidation, by aluminum killing we call it. Deoxidation means killing we call it. So there are different types of killing, but by aluminum killing we can bring down this dissolved oxygen to less than 5 ppm. Another important constituent or residual I have talked about is sulfur. This can be controlled either during pre-treatment of hot metal stage or during secondary refining. That means not during, I have, please try to understand, phosphorus we are controlling during primary steel making, but sulfur has to be controlled at the pre-treatment of hot metal stage, that means before basic oxygen furnace stage or during secondary refining stage. Another constituents, residuals which are present in steel may be hydrogen or nitrogen. They are can be controlled, these are basically gaseous elements. They can be controlled by degassing, that means you are trying to take out these elements by degassing at the stage of secondary refining. All these things will be discussed in details, but the whole idea of this particular lecture was to highlight what are the constituents which can create problem, what are the constituents which are attributed to poor cleanliness in steel, poor quality of steel. So I have tried to highlight what is meant by quality of steel. That means the quality should conform to certain application requirements, and what are the difficulties or what are the issues in understanding the quality of steel. Micro cleanliness, inclusions, surface quality, these are all important requirements. In my next presentation or lecture, I will try to go into the details of different elements. Thank you very much.